Okay, letters, like we have letters A, B, C, D, okay, P, Q, R, Y, Z, okay. So let's consider that these are some elements, okay. And how, you know that if I write some letters, for example, if I write I, J, M, so does it makes any sense? Does it any form any word? No, it is not forming any word. So compound is just similar to words, okay, in which the letters are arranged in such a manner that they give some meanings, okay. They give some meaning. Like for example, if I write uh sum, SOME, sum means little, okay. So this is a word. This is a word, okay. Like I'm just writing here pen. So pen is a word. So similarly, compounds, what are compounds? Compounds are those substances in which the elements means that is like sodium, potassium, calcium, carbon, nitrogen, oxygen. They are arranged in such a manner. They cannot arrange in any order. For example, if I'm saying that sodium and carbon, they form compound. No, they cannot form this like this compound. Okay. So compounds, the elements are arranged in a particular, in a fixed ratio that we have discussed in the previous class. They cannot arrange in any order. Okay. Like for example, if I'm saying H2O, the two hydrogen atoms and one oxygen atoms combined together, they form water molecule. Similarly, carbon dioxide, CO2, they form the water molecules. So this is carbon dioxide is making some sense, and that how to write this chemical formula of this compound. We're going to discuss this one in the next classes, okay? In the next chapter, sorry. So this is now the chapter is going on, that is matter around us pure. So let's discuss this chapter in detail, okay? So today we're going to discuss what is mixtures. Mixtures. So you know there are mixtures are the, if I say that mixtures are the impure substance, these are the impure substance. Why I'm saying this is impure substance? Why I'm saying this is impure substance? Hmm? Everybody turn on your camera. Everybody please turn on your camera. Other students also. Wait a minute, let me turn on the focus mode. Okay. Now moving to this portion here, we know that what are pure substances. So pure substances, these are impure substances. Why I'm saying that is impure substance, they are not pure. In terms of chemistry, we know that if the elements are arranged or they are chemically bonded together, if the elements are chemically bonded together, they form compound, and compounds are pure substance. But here in the mixtures, is two or more substance are mixed together, okay, mixed together in any proportion, in any proportion. There is no fixed proportion, okay, in any proportion, okay, mixed together in any proportion. Here you can say that in mixtures, substance are mixed. Yeah, substance are not chemically bonded, are not chemically bonded. Okay, they are not chemically bonded. You understood, Riaz? They are not,
Yes, sir.
they are not chemically bonded. What do you mean by chemically bond means? What do you mean by chemically bond? Chemical bond means there is a transformations of electron is taking place. Avni, you are getting my point?
Yes, sir.
This means that the electrons is being transferred. For example, if I'm saying this oxygen atom, this is an oxygen atom, this is hydrogen atom, this is hydrogen atoms. The electron of hydrogen is being transferred to the oxygen. Okay, and this is being shared. Electrons are being shared, and oxygen electrons are being shared with the hydrogen atom. So there is a chemical bond. But what happens in the mixtures? In the mixture, there is no transformation, no transformation, formation or share of electron, or no transformation and sharing of electrons. Sharing of electrons takes place. Okay, there is no sharing of electron takes place. What is going to happen? Just simple. You have this water molecule. Let's suppose this is the water molecule. These are the water molecules. Okay, and the substance are present in the intermolecular space of them. For example, if you add sugar to it, let you add sugar to it. Okay, so if you add sugar, then sugar particles will come into the intermolecular space of this water particles. Okay, so this is not, there is not a physical bond present here. Okay, there is no physical bond present. Sorry, no chemical bond, only physically bonded. Okay, got my point? Got my point?
Yes,
And
sir.
this is okay.
Sir.
So here, let's discuss further. The two or more substances are mixed together in any proportion. In mixture, substances are not chemically bonded. They are physically bounded bounded and can be separated, and can be physically bounded and can be separated by what type of method? By chemical method or physical methods? Hmm? By what
Physical
type of
method.
physical methods? Physical methods such as
Evaporation.
yes, evaporation. Okay, boiling and evaporation are same, almost same. Okay, so evaporation you can say, and by
Filtration can be used for the substances which cannot be dissolved in water.
yeah, filtration, sublimation, okay, or we can
Centrifugation.
centrifugation, decantation. Okay, there can be several other methods. Okay, so they can be separated by physical methods. Okay, got it?
So,
Got it?
sir.
Please note it down. Note it down. Note the definition of this mixtures. Okay. When you done, let me know.
Done, sir.
Okay, so let me explain you further. Here, anyone still writing? Should I move to the next part?
One minute, sir.
Okay, note it down fast. Note it down. Done? Is there anyone who's
Done.
still writing? Is there anyone who's okay, okay. Done? Okay. Now moving to the next portion is that whenever we are discussing about the solutions, okay, solution. So you know that when how solution are formed, there is always a solvent, and there is always a solute. When they combine together, they mix together, they form solution. Okay, solutions. Now, can anybody tell me that here, if I'm saying this is water, that is liquid. I'm going to give you water that is liquid, plus here it is solute. Let I'm having sugar which is solid, and this is sugar solution. Okay, so can you tell me that what is solute and solvent in this one?
Water is the solvent and sugar is the solute.
Okay, sugar is a solute. Okay, but I'm going to give you another example. Let this is mercury. Okay, mercury. Okay, and this one I'm going to have sodium. Okay, and mercury is liquid, sodium is solid, and then it forms sodium amalgam. Sodium amalgam. So what is the solute and solvent in this one?
The solvent is mercury and the solute is sodium.
Okay, Avni, if the
But
answer is
sir,
correct.
what exactly is an amalgam? Like uh, emulsion, but what kind of thing is an amalgam?
Amalgam is an alloy of mercury. Okay, when we are mixing anything in the mercury, then it is going to have the end word for this one is amalgam. Okay, so amalgam
Sure.
is solvent of, we can say that simply when mercury is added to some solution, then it form amalgam. Okay, got it? So
Yes, sir.
now according to you and other students also, this is solvent. Okay, and this is solute. So according to you, I think that the substance that is taken in more quantities is considered to be a solvent, and the substance that is taken in the small quantity is considered to be as solute. Okay, you just understood this one? Or there is a
Yes.
state?
Yes, sir.
Everybody having the same view? Munir, you also? Okay, let me explain you. Let me explain you here that the correct definition for the solvent and solute is not this one, that which is taken in more quantity is considered to be a solvent, and the substance that is added is considered to be a solute. No, this is not true. Actually, the substance if I'm saying this is solute, solute is in the liquid state. For example, I'm just coming to this slide. Okay, for example, in this slide you see that water is actually liquid here, and you add sugar to it. This is solid, and it form a solution that is called sugar solution. Okay, and that is the state of all this one is actually the liquid state. You know that sugar solution is a liquid in state. Okay, so in this condition we will consider that the state of the state of the solution is the state of solvent. Okay, state of the solution is the state of solvent. If you know that here the sugar is considered to be as what? Tell me. Sugar is
Solute.
considered to be here it is sugar is solute and sugar solution is liquid. So water is also going to have the liquid state. So we'll say that the same state of means the state of solvent and solution will be same. Okay, here you see that this is mercury when added to sodium. Okay, which is solid, it will give the sodium amalgam. So it will gives you what? It will the state for this one is also solid. The state for this one is also solid. So you must remember that this one is actually liquid state and this one is solid state. So the mercury is not be considered as solute. Here is sodium is solid and sodium amalgam is also solid. So this is solvent, and this one is solution. The state of and this is solute. Okay, now you understood. So here, keep in mind, note down that the state of solvent and solution is same. Done.
Yes, sir.
Okay, now moving to the next point is there are the types of solution. Types of solution or mixtures. So first, well, let's discuss types of mixtures. Types of mixtures. Okay, mixtures are of two types. One is homogeneous mixture. Homogeneous mixtures. Okay, another one is the heterogeneous mixtures. Heterogeneous mixtures. Okay, Aziz, why you left the class? So this is heterogeneous mixtures and homogeneous mixtures. So if I'm saying that homo means same. The word homo means same. Homo means same. So same, what is same? And hetero means different. Hetero means different. So what is the word different here means? And what is it signifying? किस word को signify करता है? Okay, let me explain you. This is different. Okay, different. So let me explain you here this one. This is homogeneous and this is heterogeneous. So homogeneous means same composition throughout the solution. Okay, and this
Yes, sir.
is heterogeneous mixture means different composition throughout the solution. Okay, same composition means uniform composition, i.e. you can say uniform composition. Okay, so what does the word uniform composition means, Avni? Are you getting my point?
Sir.
So if I'm saying here that, for example, if you are having a sugar solution, okay, this is a sugar solution inside this one, that I'm having this one. Okay, this is sugar solution. So sugar solution. Okay, so when you have this solution, okay, so when you drink it, actually the particle size is so small. When you drink it, you will find that this is the taste of from every part of this one is same. Okay, means if you drink it from the top, if you drink it from the middle, means if you take the sample from the middle, if you have a straw, let's you have the straw. Okay, if you are drinking it from the top, you will feel the same taste. If you put the straw and the bottom, if you try to use this portion, this you drink it, and again it will be same. And if you drink it from the bottom, it will be same. So the particle size is almost same. So means we can say that it is going to have uniform composition. You understood?
Yes.
Now just imagine that if you are having a solution, for example, if you have this
Sand and water.
sand and water. Okay, you can consider sand and water, or you can say that iron and sand, a mixture of iron and sand. For example, if you have, wait a minute. Okay, plugged in. Oh. Okay, so if I'm having, let's me explain you this one. That's if you are having this one is sand here, sand. Okay, and you added some iron filling to it, Okay, let you add some iron filling to it. Okay, you add some iron fillings, particles of iron. These are the iron fillings. Okay, so you see that they are not uniformly. If you take the sample from this one, you will see that there is no iron filling present here. If you take the sample from this one, you will see that there is one iron filling here. If you take the sample from this one, you will get two iron fillings. So, okay, if you get the sample from this one, you will get three iron fillings. So these are not going to have the same composition. You understood? So this is considered to be the solution. That means that uh, that this type of solution are not going to have the same composition. You understood?
Sir.
Everybody? Okay. So now we have divided this mixture, that is homogeneous and heterogeneous. Now you understood what is the difference between homo and what is it? It's indicating with the word with homo. Homo means same composition. Homo means same
Composition
composition, and
or
hetero means
uniform
or
composition.
you can, yeah, you can say this uniform or uniform composition. Uniform composition. And similarly, heterogeneous mixtures means heterogeneous mixture.
Non-uniform composition.
Yes, yeah, it is uniform composition. Very good. So everybody in the class understood? That is
Yes,
going to
sir.
have non-uniform.
Yes, sir.
Non-uniform. Okay. Non-uniform composition. Uniform composition. Let's move further and let's discuss about it further. Okay. So now we have the mixtures. Now we have this homogeneous and heterogeneous mixture we have discussed. Now further we have this homogeneous mixtures. Homogeneous mixtures. Okay, and the one is the heterogeneous. Just okay. Now you will notice here that we have divided this one into two parts. Okay, this one into two parts further. This is colloids. This is colloids and suspensions. Okay, similarly, this homogeneous mixtures has been divided into only one part, that is, it is going to have only one part, that is true solution. Okay, got it? Got it? Got it? Now
Sir.
let's discuss that why. So let me point out this one, that the true solution, both true solution and colloids are going to have the almost same features. They are going to have almost same features. Suspensions are different, but they are going to have almost same features. For example, let me explain you that what is the difference between true solution. Okay. So if I'm having this true solution here, and this is colloids. Okay. The particles of colloids, if I'm talking about the size, okay. So if I'm saying that visible with naked eyes, so if I'm saying naked eyes, I'm just going to write it in short. Just I will help, means I will write it properly. This I'm going to explain you right now first. Okay, then I will explain this. Then I will write it properly so that you will be able to write in your copy. So let me explain you first. Okay. So what I'm saying here is that both the particles of true solution and colloidal solutions are not visible. Are not visible by naked eyes. You cannot see the particles of both colloids and suspensions, sorry, or true solution both with naked eyes. Okay. Moreover, settle down. If I'm asking that does the particle settle down? Means if you
No,
keep
it
the solid.
doesn't.
Okay, yeah. If you keep it for some time, will the particles of solute get settled down? For example, if you are having a solution of salt solution, okay. So will the particle of salt settle down if you keep it for 2 or 3 hours? Tell
No.
me. So they will not settle down. Okay. So not settle down. Okay. Next. Can pass through filter paper.
Yes, sir.
Can be separated by filter paper. Tell me.
No, sir.
Filter paper? No.
Particles are too small.
Particle is too small that
Particle
can
size.
can be separated, can be separated by filter paper. Okay, so you can't separate them. The particle is so small that you can't separate them by filter paper. Okay, you can't separate them. So actually, if I'm asking that which is the property that is making the true solution and colloid same, almost they are having the same property.
Heterogeneous and homogeneous solution.
Yeah, so why we have kept this in heterogeneous structures? Why the true solutions are separated from colloids and we call them heterogeneous? Why we are saying that they are not going to have uniform composition? Still the particle is not settled down, they are not visible by naked eyes, they can't be separated by, particle is so small that they even can't be separated by filter paper. Okay, so what is that thing that is making the colloids and suspension, sorry, colloids and true solution separated? Is there anyone in the class can tell me?
They
Aziz,
cannot be separated by physical methods.
they cannot be
Colloid.
separated. They can be separated by physical method, like centrifugation methods. We can separate the blood. Blood is a colloids and it can be separated by centrifugation method. Okay, we can separate it. So Munir, Abdul Jabbar, Avni, Aziz, sorry, Ares,
Yes, sir.
Riaz, is what? Can you tell me? Can anybody in the class can tell me that what is the major difference, that how can we say that the true solution and colloids are separated? Why we have just kept this one separately? Still they are having the same property. You see that true solution and colloids are having the same property. They can't be visible by naked eyes. They can't, the particle does not settle down. If you keep the solution for a long time, the particle is not settling down. Okay, you see you can separate them by filter paper also. Then what is the difference? Why we are separating? So let me explain. So the major difference is that is Tyndall effect. Okay, Tyndall effect. So let me explain you what before this one. Let me explain you. For example, this is a dust particle, and if light is traveling, okay, light is going to have wave nature. So I'm just making this like this way. Okay, so let is light travel like this, and this gets stuck over this one. Okay, over this particle, so it will be separate. It will be scattered everywhere. Okay, and this, when this, let's suppose I'm having my eye here. Okay, so this will be visible to me. This particle will be visible to me. Why it will be visible? Because the light is being reflected. Anything that is visible to me just because light is being reflected from that substance, and that is entering to my eyes. Okay, that's why this is visible. Okay, now you understood the things that are visible and non-visible. For
Yes,
example,
sir.
if you are able to see your laptop, it means that your room light or something from this laptop means the light is being reflected from your laptop, and it is you are able to see that one. If you are able to see your books and that stuff, just because the light is being lights is being reflected. First the light fall on that object, and then it is reflecting, and then it is entering to your eyes. So similarly, this particle is visible. But how if the particle is very, very small, that it is so small that, let's suppose here it is a particle is being written here, but it is not visible to me. So what is the light will pass through it, and there will be no scattering of light will take place. Got my point? So the this scattering will take place if the particle size is enough that the light fall on it, and it is able to scatter. Okay, and the particle size is very small, smaller than this one. Then even even the light, when it fall through it, through this particle, if light is being passed, then it will not scatter the light. Okay, so similar case is seen for the true solution and the colloidal solution, and it is true solution here, and it is true solution here. Sorry, colloidal solution here. It is colloidal solution here. Okay. Okay. So for example, let if I'm having, okay, this is a solution, and let's suppose this I'm just
The
going to
true
show.
solution does not show the Tyndall effect.
Yeah, the true solution does not show the Tyndall effect, means it will not scatter the beam of light. For example, this is a torch. Okay, this is a torch, and if you are This is light beam is passing through it. Okay. So how the path will be visible to us? So example, you see that the path of light. For example, if you are having this one, you will see that here the path is visible here, and here the path is also visible. The path is also visible. Why the path of light is visible here? Because the particle size is in here is air. What is it? Here is air. Okay.
Air.
So air particles means the dust particles are enough in size that it can scatter the beam of light. So it is showing the path. Here it is also it will show the path. But no path will be visible. No path of light will be visible in true solution. In true solution. True solution. Why? Because the particle size is so small that even the light can't fall on it, and it will not scatter the beam of light. Everybody in the class understood?
Yes, sir.
Understood?
Yes, sir.
Every only 2 students, other students?
Yes, sir.
Yes, sir.
Okay, now moving to the next part. If let's suppose this is the colloidal solution. Let's suppose this is the colloidal solution. Now I'm just making the particle inside also. Okay, so when the light beam is passing through it,
Path will be visible.
yeah, the path will be, so the path will be visible. You'll see that the light path will be visible to us. Okay, so the path of light will be visible. Path of light, right, will be visible to us. Visible to. Okay, so this is called Tyndall effect. What is called? This path, the path of light that is visible to us, that is called Tyndall effect. That is called Tyndall effect. Are you understood? Tyndall effect?
Yes, sir.
Okay, so this is called Tyndall effect, and there will be no Tyndall effect to be shown. Okay, so this is the major difference of colloidal solutions and the true solution. This is the only difference I can say simply. Okay, so the major difference means the main difference that why we have kept this colloidal solution into the heterogeneous mixture, because the particle size is so enough that it can scatter the beam of light. Okay, so if I, in simple word, if I'm going to say the definition of heterogeneous mixtures is that the particle size is large enough that it can scatter the beam of light, then it will be considered as heterogeneous mixtures. Uniform composition will comes after this. Okay, because here the colloidal solution have the almost uniform composition. Okay, we can simply say that colloidal solutions also have the uniform composition. Okay, but they will scare the why we have still why we are just keeping these one into the heterogeneous mixture, just because they are scattering the beam of light. Okay, got it?
Yes, sir.
So let's move further, and let me help you to write this the answer for this maybe too. Yeah. So please note it down. Note the difference between the true solution, colloids, and suspensions. Note the difference. Particle do not settle down, particle do not settle down, particle settle down. In suspension is just, you see that like a soap solution, we have suspension. Okay, and you know that when we have a soap solution, or a sand in water, you will keep the water, the mixture for some time. You will see that the particle of sand will settle down after some time, or the soap solution will, the particle of soap will settle down after some time. So see, the particle will settle down here, can't be separated by filtration, can't be separated by filter paper, and this suspension can be separated by filter paper. Okay, they have uniform composition. Okay, like solid and liquid, sugar and water example. Okay, they also have the uniform composition. So both are going to have the uniform composition. Okay. They have the uniform composition. They have the uniform composition. But the major difference is they don't have the uniform composition. Okay. So note it down. It do not scatter the beam of light. It scatter the beam of light. Both of them are scattering the beam of light. That's why they are considered to be as heterogeneous mixtures. Everyone in the class should notice that everyone has to write the class work properly in your copy. Don't mix your physics, chemistry, and biology copy. Make it separate copy for this one. Okay. And moreover, maintain your notes properly. Okay. This is important. When you're done, please let me know. Okay. Mention about the particle size also here. The particle size of these, of this true solution. Okay, and the collider solution. Let you write first, then I will help you. Right. Done, everybody in the class?
Still doing 1 minute.
Okay, okay.
Just 2 minutes, almost done.
Like we have the filter paper, there is also a parchment paper. Parchment, okay? Parchment paper. So the true solution can not be filtered by both filter paper and parchment paper. But colloidal solution can be separated by parchment paper, but not by filter paper. Okay. Means we can say if we want to separate it, the colloidal solution can be separated by parchment paper. Okay.
But so parchment paper is like a butter paper. So
Yeah.
how can it be used for filtration?
Actually, the size is very small that you see that uh, it is like just like the butter paper, but it is going to have some holes inside it and it can be separated. Okay. So parchment
Yes, sir.
paper, you think that according to you, you feel that the size means you can't separate it, but it can be separated through it. Okay.
Okay, sir.
Actually, the size of filter papers, the holes of size means this holes in filter paper is bigger in size, so we can't separate the colloid from it. Okay. So have you written everybody this in the class, or should I move to the done? Mm.
Yes, sir. Done.
So done. Okay. So note an extra point here. Note an extra point that I'm just going to clear the space of this one. You know, this is the space of colloid. Okay, this is. So write down in the colloids. Sorry, in the true solution can't be separated by parchment paper. Okay, and this is can be separated by parchment paper. Okay, so this is important because this one is a specific condition that almost others are same. So we need to write this one also. Okay, so that true solution even can't be separated by parchment paper, but the colloids can be separated. Okay, got it? Done. Now you know the examples of what give me some examples of homogeneous and heterogeneous mixtures.
Homogeneous mixtures can be
Examples only.
what?
Yeah. What?
Lemonade, water
Yeah.
plus salt, or water plus lemon water. And
Okay.
heterogeneous mixtures can be chalk and water.
Okay. Okay. And know the examples of. Okay. Let's discuss. Done, everybody. Should I move further?
Sir.
Yes, sir. So true solution can again be sugar plus water. Colloids can be milk plus water, or milk of
Milk itself only. Milk.
magnesia. Yeah.
Yeah.
And suspension can be chalk plus water.
Okay. So let's discuss further. That is common examples. Common examples of colloids. Okay. Let's discuss this one. Common examples. Common examples. Examples of colloids. Okay. Now, if I'm just going to discuss here, that you will notice that you will, you know that I'm just going to write here that is solvent, or I'm just going to write here that is solute. Okay, and then solvent, and then solution. Okay, got it. But these are the examples of colloids only. Okay, so if I'm saying that liquid, some liquid, if this solute is liquid, okay, and this solvent is gas. Okay, so what should be the state of this solution? Will it be gas or liquid? Solute is liquid and solvent is gas. So will the solution be?
Gas.
Yes, it will be gas. Okay. So here, just giving an examples, and this type of colloid is called aerosol. What we called it?
Aerosol.
aerosol. And the example for this one is just like fog. Fog. Okay, you understood?
Yes, sir.
Fog. Similarly, clouds. Clouds are another examples. Okay,
Yes, sir.
like fog. Fog. What is clouds? Cloud is just simply the
Water.
water particle
Yeah.
get mixed with the air.
Air.
Okay, similarly the fog also same. Okay, and next one is solid. I'm going to have solute is solid and solvent is gas. Okay, solid and gas. So this type of mixture will be considered to be as, again, the gas is here. Okay, then it is all again considered to be as aerosol. Okay, example for this one. Will it be solid or liquid or gas? Solution state.
Gas.
Gas. It will be gas. Okay, now example. Any example for this one? Other students, why are not replying? Abdul Jabbar, Munir, Avni, RS. Tell me, if this solvent is gas and solute is solid, what would be the state of this solution? So similar state. Avni, are you there in the class?
Dry ice.
No, I'm not asking the examples. I'm just asking that what is the state of this solution? When solid is mixed in gas, what is the state? Will it be gas? Will it be solid? Yes, Shita,
Yes, sir.
are you saying something?
Yes, sir. Gas.
Yes, it will be gas. Okay, very good. So this will be gas. Why? Because the same state, the solvent and solution are going to have the same state. Okay, same state. Okay, so can you give me the example of this one? Anybody? That what should be the example of this colloids? That is smoke. Understood? That is
So
smoke. Okay, smoke is an example for this one. Now let's having the gas and liquid. Again, gas and liquid. Now what is the state? Avni is going to tell me. What is the state? Avni, what is the state of? What is the
Gas.
state of? No, we have mixed the
will
gas into liquid. Liquid is solvent. Okay, so what is the state of the solution?
liquid.
Liquid. Yes. Okay. So examples, and don't think that it is carbon dioxide mixed in water. No, we are just giving the example of colloids here. The particle is large enough. Okay. So again, that will be considered to be as foam. This is aerosol. This is foam. Foam, and this is, you can say, this shaving cream, like shaving cream. Okay, example for this one. Okay, gas when mixed in liquid, they form foam. You don't think that we are just mixing the carbon dioxide in water. This is not a colloid. This is a true solution. Okay, got
Yes,
it?
sir.
Okay.
Now moving further, we have liquid, liquid and liquid. Liquid and liquid mixed together.
Emulsion.
Yes, it will be emulsion. So emulsion. Okay.
Milk of magnesia.
Yeah, milk. Milk of magnesia is magnesium hydroxide when mixed with water. Okay. So actually milk of magnesia, here you can say, like we have milk. Example, next is face cream. Face cream. Okay. So these are the examples that emulsion, you know that the liquids are mixed together, but they are not uniformly mixed. Okay. They are forming
Sir.
having cells. So okay, that is called emulsion. And like face cream, we have milk. So liquids are like we have fat. Fat is in the form of liquid, and that is mixed in the water where, and proteins are mixed there in the milk. So you see that here the liquids are mixed together. Okay, now moving to the next point. Have you noted down this one to here? Everybody in the class?
Yes, sir.
Next.
So
Next.
we'll just require 2 minutes to write this down.
Okay. Note it down. Now this is solid mixed with liquid. Okay. Solid again, solid and liquid, they are mixed together.
Liquid.
Okay, then what is it? The state of that is liquid. And what is the what we called it? We'll call it soul. Okay, soul. An example for this one is like mud. Okay, solid mixed in liquid, that is forming mud. Like we have mud, digen. Okay, digen, etc. Now moving to the next one is like we have the gas mixed in solid. So gas mixed in solid will form what? Again, you see that
Solid.
gas mixed in solid. Okay, and here you see that
Solid.
here you see that here actually when the same substance are mixed, like you see that gas mixed in liquid, aerosol. Okay, oh here it is gas mixed in solid and okay, gas mixed in, then it is again it will form again form gas mixed in solid, it is form. Okay, form. Now the state will be solid. It's because the solvent is going to have the solid state, so it will be form. But example for this one will be like rubber. Okay, rubber, sponge, etc. Okay, rubber, sponge, etc. You understood?
Yes, sir.
The last one I'm just going to write here. That is okay. Note it down in the previous one because we can't. I can note it down. And the last one is liquid. Liquid mixed with solid. So this will be gel. Gel is almost solid in shape. That is jelly, cheese. Okay, etc. Please note it down. Done.
Yes, sir.
Everybody writing?
Sir.
So again, liquid when mixed with gas, liquid when mixed with gas. Okay, the solvent is gas, so the fog is an example. Okay, fog is also a gas, cloud is also gas. Like if you do solid mixed with gas, then again solid and gas, solvent is gas, so the solution will also a gas, that is smoke. Gas and liquid, so liquid is solvent, so the solvent is, so the shaving cream is an example because it is also liquid in state, shaving cream. Liquid and liquid emulsion, that is milk and face cream. Solid and liquid sole, that is mud, hygiene. It is liquid, this is also almost liquid. Mud, I'm not saying mud is just like when solid mixed with liquid, that is simple, so that is called mud. Okay, that is again gas mixed with solid. Okay, that is forming the foam, rubber sponge. Example for this. Okay, now you understood, everybody understood?
Yes, sir.
Is there anyone who is still writing? Is there anyone who is still writing?
No, sir.
Done. So what we're going to study in the next class, let me explain you that what we're going to study in the next class. We're just going to, there are some concentration terms. Concentration terms. Okay, there are some concentration terms that we not need to understood this one. So as you know very well that we always have some calculative terms for measuring that how much amount of solute is present in a solution. For example, if I'm saying that 2 grams of sugar is present in 100 ml of water, and if I'm saying 2 grams of sugar is present in 10 ml of water, so which is more concentrated? So you will say that 2 grams of sugar is present in 10 10 ml of water. So this is more concentrated. So we always have some terms. So there are three types of terms that we're going to study in the next class. That is mass percentage, mass by mass percentage. Second is mass by volume percentage, and that is volume by volume percentage. And okay, these three terms are important. Next one is solubility. Solubility also we're going to study in the, this is a fourth one. This is 1, 2, 3, and this is fourth one that we're going to study and discuss in the next class. So in the next class will be the numerical portion, because at this time from this chapter, the separation techniques has been removed. So we're not going to discuss that one, because according to the NCERT and the CBSE syllabus, that is has been removed. That portion has been removed from this. So we're going to discuss this in this topic that is coming in examination.